it works in the lab, but it may not work at large scale.
Yes,
That's the problem a lot of people face.
So there is a difference between invention and innovation. What academics typically have been doing really well for a long period of time is invention, the breakthrough in the lab. It is only an innovation if it works comparably or even better at larger scale.
You're listening to Bite Size Climate Tech, Season 5.
Welcome to the show, Vikram. On this beautiful sunny day, you travel from Canada who brought the sun to London.
Yes, I brought the sun and I'm hoping that I'll take the sun back with me too.
For background, Vikram is a serial entrepreneur, a scientist, a professor.
Pleasure to meet you, Lydia, in beautiful London as always. So I am Vikram Yadav. Vikram Yadav is how I go. I am a professor at the University of British Columbia. And as you mentioned, I have a very strong focus on climate technologies and translational focused research. So all the research that we do, we deliberately try to translate that to the market.
Yeah.
And we do that through the engine of startups and commercialization.
Oh, wow. That's perfect. We need more of those technology into the real world.
Agreed. And so that has been something which my team has been very conscious in doing. So every piece of research that we do, the first question that we ask is, how is this going to be a real product that is going to have impact in the real world? So my research program at UBC, fundamentally, we look at applying biology and biotechnology to solve problems in manufacturing. This also extends to manufacturing better products and materials. A related concept is in sustainability and waste reduction, eliminating waste.
Yes. So this specific technology is called...
This is intelligent bioprocessing. We use genetically engineered microorganisms, also now popularly known as synthetic biology.
Okay.
And we develop a bioprocess around that microorganism.
Okay.
And now you could call this as clean bioprocessing or sustainable bioprocessing.
So we're going to talk about the sustainable bioprocessing today on the podcast.
Yes.
As far as I know, you use this to apply to shell waste, the shell of like shrimps and... Crustacean
and insect shells, correct.
Yes. And what exactly is the process?
Indeed. We're in this beautiful setting. At some point, somebody is going to order seafood and all of these very nice things. So as you can imagine, if you go to any typical seafood restaurant, there is going to be a lot of waste, shell waste.
Yeah.
Now, all of us often wonder, like, what happens to the shells? It's a really hard protective material. That is comprised of a natural material called chitin. Chitin is the second most abundant biopolymer on the planet.
Oh, wow.
And chitin, as you can imagine, we cannot digest chitin because we don't have the machinery to do so. But chitin actually becomes a very important building block. Now, we take that crustacean waste.
Yeah.
We have identified and engineered a microorganism.
Right.
This microorganism, we feed it this waste.
Yeah.
It goes in and it eats all of the proteins. It removes all of the minerals. There is a very intelligent way in which the microbes is taking all of the waste. And what it leaves behind is a very specific form of chitin. That chitin is called nanofibrillated chitin, or NFC.
Okay.
And now what nanofibrillated chitin does is that it is, because of its physical properties, it has some very interesting applications. Two illustrative examples of application. So let me start with what is nanofibrillated chitin.
Yes.
So imagine you have wood. Now all of us are familiar with wood chips. Do you take a mound of wood? It's all wood chips. Now imagine I tell you to take those wood chips and I say, make a nice uniform carpet layer or cover the table. There are going to be imperfections.
Yeah.
It's not. Now if I take that wood and I use our clean processing and I produce these nice pencils, elongated pencils. Now I tell you, can you take these pencils and cover your table with it? It'll be very easy to do it. So that's what that fibrillated form is. It is in this nice pencil fiber type form. Which makes it exceptional as a material for coating.
I see.
And now when you extend that, it can produce gels. It can produce all sorts of very nice creams and bases. A major application for our product is in the world of cosmetics. Can you imagine a cream or a lotion or some sort of makeup that is able to coat very nicely, very smooth to the touch, and has exceptional properties. And that's what one of the applications for chitin is.
Yeah, okay, got you. It's almost like your technology make it easier for you to extract the most valuable ingredients from this waste.
Correct.
Also efficiently.
Very efficiently, and it's a clean extra, so it is replacing the dirty chemical extraction process. Now, where is it superior to the conventional thing? Not only is it very efficient, it doesn't generate any of the waste. So when you're looking at in terms of chemical use and water use, which is a tremendous problem in the world, we are reducing chemical and water use by well over 90 to 95%.
Wow. What was the process before?
So before,
there's no process.
There is a chemical extraction process. You use a lot of acids and alkali to extract it. And that is extremely polluting because the waste disposal costs start adding up. What we are doing is we're taking this abundant feedstock, this resource, which is crustacean shell waste, and we are producing this material cleanly with very essential applications.
Now that I understand, but how do you explain this to an 8-year-old?
So every 8-year-old on the planet, they love cookies. Like I have 2 young kids. If I take them to a bakery, the first thing they pick out is a cookie. So all of us knows the cookie with the M&Ms.
Monster cookie.
Right. So now, let's say that you're an 8-year-old kid. Let's be honest. You're 8-year-old, you only want the M&Ms. You don't want the cookie.
Or the chocolate in the...
Right? The chocolate, the chips that are in there. So our bacteria that we've engineered, we get the bacteria, it goes in and it eats everything in the cookie and it leaves behind your favorite M&M
the chocolate and all the gems in
and all the gems in there. And then
cookie.
you go in happily enough, all the other stuff is gone, and then you feast on your favorite chocolate. And so that's what our technology is.
I think your technology is one step further. It's not only take out the M&M and the chocolate, but also make it easier to eat.
Easier to eat,
even better.
Improves the flavor.
Improves the flavor.
All of that.
It's like the chef.
Yes.
Climate tech is just good business! That's the bottom line.
But always I wanted to know how much better it is compared to the previous solution. Of course, it's clean, but people have this question like, is it more expensive? Is it less efficient?
Our development plan has consciously focused on the biggest challenges that face climate technologies and bioprocessing, which is scale up. And it's funny, instead of us taking a process and thinking linearly in the forward direction, we have worked our way backwards. So we have said, if we want to operate a process at this scale, producing so much material, how are we going to get to those scales, and what are some of the biggest challenges that we need to solve in order to get there?
This is brilliant, because usually when people say, oh, it works in a lab, but it may not work at large scale. That's the problem a lot of people face.
That is a fundamentally new paradigm that we have brought. That is essentially emblematic of the research ecosystem that we are even building in my lab here at UBC, where the approach there is, don't just think of the innovation as, oh, I've made a breakthrough in the labs. So there is a difference between invention and innovation. What academics typically have been doing really well for a long period of time is invention, the breakthrough in the lab. It is only an innovation if it works comparably or even better at larger scale. And so think about what is that engineering that is needed to take it up to make it an innovation. So that invention to innovation, that transition is something that we've been focusing on a lot. And we've developed some very unique expertise to that end.
A question from our previous guest.
If there was one thing you could do to have a positive impact on the climate, what would it be?
Now, pass it on to our next guest.
So I'm going to be biased in my response. I am a scientist, an academician, and so I am deliberately going to give this message to people who are students, engineers, scientists who are working in a university lab, who are trying to commercialize their technology. As academicians, as scientists at the bench, we're brilliant as a community, but many of us are afraid of what is going to happen if this doesn't work at scale. And I see this over and over again with students, with brilliant individuals, and
Yeah.
my advice to them is always the same: be bold to ask those questions,
Yeah.
and trust yourself and your ability that you will solve those questions. You will find the answer to those questions.
Wow. Be bold.
Be bold.
Nice. I like this. Can you leave a question for the next guest?
What is it that you will tell the next generation to get them excited to join the climate tech bandwagon? What is going to be your recruiting message to them?
What would be your answer for this?
My answer to this is it's layered. Why am I saying this? Because as a university professor, I deal with I am constantly surrounded by young people.
Yes, yes.
What I have noticed over the last 10 years is that these young people are very afraid and unsure about what the future holds. Look at the world.
Understandably,
Look at the current geopolitical environment.
Yeah.
Look at the
Yeah.
climate.
Yeah, yeah.
Look at the economy. And so many of these individuals are graduating, very, very capable individuals and intelligent individuals. But they're uncertain about their future.
Yes, yes, yes.
My recruiting, so when you try and go out to them and you tell them, you know what, you need to solve some of these problems, many of them come into the profession thinking, is this really something that I can do? Is my effort going to make a difference? And you're seeing and you're hearing a lot of this around the world.
Yes.
So my message, I have 2 young kids and I tell them the same thing.
Yeah.
We need more capable, intelligent people doing it. It is the only way we as a civilization are
Can
going to
survive.
solve these problems.
Yeah, exactly.
And the best ideas are yet
to be
to
invented.
be brought into
Yeah.
the market. They've yet to be invented.
Uh-huh.
So come along.
Yes.
And there has never been a better time to be alive than today when
Exactly.
it comes to being a technologist.
Yes.
You're seeing the rate at which technology is changing. Technology is truly powerful. It can
Yes,
change
yes,
the world.
yes.
And we need good people, ethical people developing technologies the right way so that we solve the right problems.
Oh, I love this.
So that's my recruiting pitch.
Yes.
You as an individual have the power to change the planet.
You have the power to change the planet.
Why do you work in climate?
Like, what was your recruiting message at the time? Who recruited you?
So it's funny. I have a story actually. So I started.
please.
So I did my undergraduate degree in chemical engineering from the University of Waterloo. This was a program where you would do class activities and then you would have stints in the industry, which we call co-op terms. Okay.
Right.
So I went on an industrial training right after my first year, and it was in Imperial Oil, which is ExxonMobil.
Okay.
So I started my career in oil and gas. It was interesting engineering work, but at the end of the day, when you're looking at the grand picture, it didn't feel fulfilling. So there was always that thing about, what am I doing? Like, is this, because many of at least the department where I was based was very routine work.
Yes.
And so it was not even a question about the environment or the planet. It was about, this is routine, boring stuff. What am I doing?
Yeah, corporate job.
Right? But so then one of these semesters, I ended up working in Sanofi, which is a big vaccine manufacturer. And that's where, that was my first taste of biotechnology.
Yes.
And I found this to be really captivating. And I said, okay, now I like biotechnology.
Yeah.
But still at no point it was climate. It was just biotechnology.
Yes.
And then I happened to read this very interesting book, which is an interesting book because calling it a book is actually, it's marginal.
Yeah.
The title is called As the Future Catches You.
Wow.
The author is Juan Enriquez. Juan Enriquez was a business partner of the great Craig Venter. Juan Enriquez wrote this book about how biology is going to transform the world. And that's why the title, As the Future Catches You.
Oh.
And the book, every page is one sentence. It is written in like font 25.
Oh, wow.
Every page.
Really?
So you can finish that book in like 25 minutes.
Nice.
It's like about 100 pages and 100 sentences.
Yeah.
But every sentence has been thought through. And what it says is, and there the connection is biology, planetary scale problems, planetary scale solutions. I read that, I came out saying, this could be the engine for how you can solve global scale problems in health,
Yes.
agriculture, food, climate, carbon capture, all sorts of stuff. And that's what really got me keyed in. And that has been a driving force ever since. And now my motivation to continue working hard are my kids.
Yes.
I
yes.
want to leave the world in a better place for them.
It will be.
And they are my inspiration to continue working. So that's what keeps me passionate about the field.
Amazing. Did you pick up this book yourself, or it was given by someone else?
I happened to chance upon it in the library. I was trying to get books on biotechnology just to read and self-educate. And the title stood out. It sticks out, like as the future catches you, in a section on biotechnology.
I love this title.
It just sticks out. So that's why I picked the book.
What's your one sentence of hope?
So the one sentence of hope was probably the recruiting campaign that I mentioned to people.
Yes.
That there has never been a better time to be alive because technology is being developed and matured at incredible pace. We are having a huge collective of very intelligent people who are working on the climate problem. The answer is that just as the planet, the people who work on climate are a resilient bunch.
Yes.
We are going to be here.
Yes.
So let your resiliency shine through. There are going to be many more great minds that are getting trained. They will come.
Yes.
They will develop solutions, and we will
prevail. Yes.
the old sins that we have done against the planet.
Yes. We're a resilient bunch.
We are a resilient bunch, and we will do it. And we have to do it with a smile on our faces. It's very easy to get cynical, so we have to just...
We need to keep the hope going.
We need to be hopeful, because there is a lot to be hopeful for.
Exactly. That's what I think too.
Yes.
Let's make climate cool again. High five.
Yes. Wonderful.
Nice.
Let's make climate cool again.